In the last video, we answered the question, at any time t after launch, where is a projectile? And in this video, we're going to answer, what is a projectile's velocity? Those are different questions. Where something is and how it's moving are not the same thing. So we're not going to use the same process here as we did in the previous video because we're finding something different. The previous video was about where is something, and whenever we were finding where is something, just to review ever so briefly, we used that dx equation and we used this dy equation. We're not going to do that here because what we're finding is, what is a projectile's velocity? The way you do this is you calculate Vy final. And then for sure, you Pythagorize it with Vx. Pythagorize is a verb that I made up, but it's a very good one. And maybe you'll have to inverse tangentize it too. If I ask for speed, or if I ask how fast is it moving, then you'll only need to Pythagorize. That's it. If I ask for the velocity, then you're going to have to do both. Let's show you how this is done. Same set of golf clubs that we launched before. Now we want to find its velocity 2.43 seconds after launch. Previously, we wanted to find out where it was 2.43 seconds after launch. Once again, what we do is we sketch out the initial vectors, and we want to use our sine and cosine to figure out what the Vx and Vy initial are. Vx and Vy initial. We did this in the previous video, but let's go ahead and do it again real quickly here. Vx is going to be 35.58 times the cosine of 55.8, and that came out to be 20 meters per second to the right. Vy initial, again, we say initial because it's only good for that first instant. 35.58 times the sine of 55.8, and that came out to be 29.43 meters per second in the upward direction. 29.43 meters per second. And I'm going to say that upward is positive, which means that 29.43 is positive, but my acceleration is going to be negative. So we have to determine Vy final. Now, how do we do that? We use the equation that's right on the top here, right there. We know the acceleration in the y direction because we're assuming we're on Earth. We know the time because it's given, and we also know Vy initial. So we're going to use this equation. Ay Vy final minus Vy initial divided by time. So what's Vy final? Vy final, can we solve this for Vy final? Multiply by t and add Vy initial to both sides? You check and make sure you're okay with that. Vy initial is positive 29.43, and here again, we have to be really careful because the acceleration, as we've defined it, points in the negative direction, therefore it's negative. This quantity here is a positive number, that quantity there is a negative number. And when you type this into your calculator, you get something like 5.59 meters per second. Now, what does that mean? Well, what it means is that this set of golf clubs is still on the way up. It hasn't reached the top yet. So to find the velocity at 2.43 seconds, what does it say to do? We're supposed to Pythagorize. Oops, there it is. We're supposed to find VYF. Did that. Now we got to Pythagorize it with VX. Let me sketch it out real quick, can I? Here's VX. That's about 20. And VY final is only 5.59, so that's a little guy like that. 5.59 meters per second, and this is 20 meters per second. So the vector we're finding is that one right there, and we're also going to want to find that angle in there in just a minute, but let's Pythagorize those two. So V is equal to 20 squared plus 5.59 squared, square rooted. And when you do that, you get 20.8 meters per second. That's how fast it's going. And then how do we find the angle? We did this a lot when we were adding vectors. We take the inverse tangent of opposite over adjacent. We want our angle in degrees, so we want to make sure our calculator is in degree mode. You check it out. It comes out to be 15.6 degrees. 15.6 degrees what? Above horizontal. That's the velocity of that set of golf clubs, 2.43 seconds after we launch it. Let's do one more. Same scenario as in the previous video, except in the previous video we were figuring out where this projectile was, and now I want to know how it's moving after launch. Vx is 36 meters per second. That height is 92 meters. Since all of this motion in the vertical direction is downward, I'm going to say downward is positive, which means my AY is going to be positive, 9.81. If you want to make it negative, that's fine. There's no problem. So what are we supposed to do here? What does it say? Find VY final. And what equation should we use to find VY final? This first one right here. Let's do it. AY is VY final minus VY initial divided by the time. We know the time. We're told it right there. 3.24 seconds. So what's VY final? Multiply both sides by T and add VY initial to both sides. What's VY initial for this case? It's a horizontally launched projectile. 0. So VY final is nothing more than 9.81 meters per second squared multiplied by 3.24 seconds. And when you do that, you get 31.78 meters per second. And it came out positive because it's downward. And positive is downward. So we found VY final. Then what did we do? We got to Pythagorize it with Vx. And then, does it say we need a velocity? It does. You see where I'm pointing? Right there. Velocity. So that means not only do we need to Pythagorize this with Vx, but we then also need to inverse tangentize them. So let me sketch these out. Vx, check it out. It's at the top of the screen. See that? 36 meters per second. So there's 36 meters per second. Remember that doesn't change. And Vy final is 31.78. So 31 is going to be slightly shorter than 36. How about like that? 31.78 meters per second. The vector that we want is this guy right there. And we're also going to have to find that angle below horizontal, aren't we? I trust that you can do that. If you Pythagorize those, I'm looking at the original problem now. You see this in the upper left where I'm pointing? 2 significant figures. So I trust that you can use the Pythagorean theorem on there to get 48 meters per second. Let's go ahead and do the angle. How do you find the angle? Inverse tangent of opposite over adjacent. Make sure your calculator's in degree mode. Just for food for thought, should this angle come out to be greater or less than 45, hopefully you can convince yourself that it should be slightly less than 45. And it is. If you calculate it, it comes out to be 41 degrees to two significant figures, but that's not enough. 41 degrees below horizontal. That's how you do it.